start this session. Almost many people are here already. Okay, so what we are going to see is some of the basic things about ad hoc sensor network or ad hoc wireless network. So please take down the page number. Page number is from 206 to 227. Whatever I am teaching in this first session, it will be between this 21 pages. So page number 206 to 227. Whatever book I have sent to you, in that PDF only, you will be finding all these details between page number 206 to 227. If I'm not audible, sometimes please let me know through the chat window. Okay. So first we'll see what is meant by single hop, what is meant by multi-hop, and what is meant by multi-path propagation. As a diagram shows A as single hop, diagram B is called as multi-hop. So in diagram 1A, you can see that left side there is a source. So this triangular thing is a source, and this is actually a node with some 5-10 sensors, and this sensor also is having a communication module attached to it. This sensor is having microprocessor attached to it, and whatever sensing is done, that sensed data is processed by the microprocessor or microcontroller, and then it is transmitted to the destination by some kind of communication protocol. That communication protocol can be Zigbee, that communication protocol can be LoRa, it can be infrared, it can be I am audible, I think, isn't it? My mic is unmuted. Hello. Okay, so whatever thing you can see in the screen, so the first there is the single hop propagation, and below there is multi-hop propagation. So single hop propagation is actually sending the data from one place to another, and this is a direct kind of communication. There is no repeater node in between. So as you can see in the top, you are finding that from the source to destination there is only one path or one jump. Okay, so for any source or for any communication protocol, this length is defined. So it can be 10 meters. So one hop jump can be maybe 10 meters or so. Okay, sometimes the one hop jump can be 2 meters. So if from source to destination, if in the second case you are finding it's multi-hop, uh, hello. Okay, so screen is visible. I am audible, I think. So I'll go ahead. So you can see here in the diagram I have shown a single hop and a multi-hop. So single hop means from source to destination there will be only one jump. Okay, and this hop is defined for any sensor node. So if it's a Zigbee sensor node, Zigbee suppose is sending data over 50 meters. So I'll say that the single hop is having a jump of 50 meters. But let's say in the second case, what is meant by multi-hop? So between source and destination, suppose distance is 250 meters. In that case, from source to destination, I cannot jump by one jump because all the sources, all the sensors are having a Zigbee fitted to it. So communication module used here is Zigbee. And we have controlled the power of the Zigbee in such a way that Zigbee can jump only for 50 meters. Okay, so from here to here, if you want to go from source to destination, maybe you have to take 5 jumps. So here I have shown 3 jump, but if it is 250-meter and each jump is predefined, it is suppose 50-meter. So to cover 250-meter, it has to take 5 jumps. So here I have shown 3 sensor nodes and 1 destination. So destination also having transmitter receiver mode. Each of the sensor nodes are also having transmitter and receiver mode. So and each of the destination nodes, source node, repeater or peer node. So in between whatever sensor nodes are there, they are called router, repeater, peer node. There are different names and these names are not very fixed. Okay, so they are kind of a flexible kind of a thing. So it can be called as router, it can be called as repeater, can be called as peer nodes. So each peer node is having sensing, microcontroller, and transmission, reception, all capabilities. So here I send data from the source. So here I've sensed some data. The data I'll transmit here over 50-meter distance by this Zigbee module. Then this will send it to the second, and then this will send to the destination. So this 150-meter distance is covered by 3 hops. So whenever you are doing multi-hop kind of a thing, in that case I have to ensure that all this in between nodes or all these peer nodes, repeater, router nodes, they are active. If suppose this first peer node is dead, then even if we try to do multi-hop propagation, it will not happen. So this is a collaborative kind of signal sensing and transmission, and at the same time the source senses and sends the data. It is possible that this source data and peer node is also sensing some data. So this data and this data together will be given to the third node or second peer node, and this peer node is also going to sense some kind of data. So all these 3 sensor nodes sense data, they will be together coming to the destination. So as the hop is increasing, the amount of data or the volume of data is also increasing, and all together they will be sent to the destination. So this is multi-hop propagation and this is single hop propagation. And the notations I have used here is triangle thing is a sensor, and this rectangle thing with cross symbol in between is a base station. So base station is something where all the data are being dumped. Okay, and base station is having a very big microprocessor or microcontroller based system where all the sensor node data are processed together and inference is found. Inference means what is the decision. So you are sensing a lot of data for a certain geographic region, but exactly after sensing all the data, what to do with that? So with all those data, once we are mixing together, then at the base station some algorithm is being run. So here actually we require that data processing kind of thing. Here we require that big data and data science analytics. Here we require database management system. All these things are required at the base station for data processing kind of a thing. Okay. So because all these big algorithms, all this big decision making thing, they require a lot of computing power, and that computing power requires a lot of energy. So that energy, big battery and all those things we cannot put at this sensor nodes which are deployed in the field, because these sensor nodes are energy constraint, these sensor nodes are bandwidth constraint. Their job is just to sense the data and relay it to the base station. Base station is also called as sync node in case of wireless sensor network. In case of ad hoc wireless network, it is called as base station or called as BS. Okay, so at this base station, all the big algorithms we run, data analysis we run, and we take out the inference, means decision about exactly what is happening in this region, and whatever data we are sensing, we try to take out a decision from that. Okay, so this is about single hop propagation, multi-hop propagation. If question asked, you have to write in detail about single hop and multi-hop propagation. What is the biggest difference between single hop and multi-hop? Is one thing is there that single hop is one jump, multi-hop is many jump. Single hop energy requirement is comparatively less, and single hop is more stable, and single hop is not depending on collaboration. Where if you see multi-hop propagation, that requires a collaboration between many sensor nodes to send the data from the source to the destination. So multi-hop propagation is kind of a team game, whereas single hop propagation is a solo kind of game. Okay. In multi-hop propagation, if one sensor node is down in between, so the whole link. So this is called link. Whatever jump is shown, whatever arrow jump is shown, this is called one communication link. So if one sensor node is down in multi-hop propagation, then all the previous link, whatever transmission they are doing, it's of no use, because if this link is down, then all the previous data cannot go to the destination. So link design, how much power is required to transmit some kind of data, link design and sensor node design, sensor, we have to keep the sensor alive. All these issues are very important in case of multi-hop propagation. So multi-hop propagation is comparatively a little bit more complex, and single hop propagation is comparatively little easy. Okay. Another diagram of multi-hop propagation I have shown below. So if you are asked a short note, you can show like this. So you can see that this is a starry kind of thing. This is a overall sensor area, overall area which is being uh, tracked by this many sensors. Let's say within this starry area, we are trying to find out how much is the temperature at this point 1. So point 1, whatever is there, here is a temperature sensing node with microcontroller, with communication module and all. And here I am sitting, maybe I am sitting at London, okay, and this is a agricultural field which is there at India. So just by sitting at London, I want to check what is the temperature of this field which may be there in Karnataka. So what happens is, this point temperature I want to pick up. So this point temperature is sending the data here. So this is 1 hop, 2 hop, 3 hop, 4 hop, and then 5 hop. So there are 5 nodes, 4 are peer nodes, 1 is sensing node. So all this intermediate peer nodes also can be sensing the data at different points. So all this chunk of data come to this gateway. So this is the gateway. So this is a base station or gateway, you can say, gateway of sensor node. So all this data is being dumped. So through this gateway, all this data, area data, is being connected to the internet or web or cloud. And I am sitting at London and I am retrieving that data about this paddy field or agricultural field sitting at a very far place. Okay, and here how many hops? 1, 2, 3, 4, and 5. After 5 hops, the whole data is coming to the gateway. And there are two kinds of communication possible. One is only the data sensed data at 1.1. This is being relayed by all the sensors. This is one type of communication. Second thing, sense data at 1, sense data at 2, sense data at 3, 4, and 5. All this data are being bunched together and they are being sent at the gateway station. So it depends on data handling capacity of this link. So there are 5 links. These arrows are called as links. There are 5 links I have shown. So if the data handling capacity of the link is good enough, if good enough of bandwidth is allocated to this each of the link, then at every point the data is being entered in that link, and the amount of volume of data is increasing, and all the data together is being sent to the gateway or data sync or somewhere, and that is being uploaded through the cloud, and through cloud I am accessing the data at some other point. So this is called as WSN multi-hop propagation. 4 hops, actually 1, 2, 3, 4, not 4 hops. There is a mistake. Actually, there are 5 hops from the sender to the receiver. So the same temperature data is being sent from the sender to the receiver by using 5 different hops. So this is single hop and this is multi-hop propagation. I might not be giving you detailed notes for this thing, because if you explain the diagram, I think that will be enough. And any book or our book also, page number is already given, 206 to 227. You'll be getting all this explanation about single hop, multi-hop. There is another thing which is called as multipath propagation. So single hop, multi-hop, and what is meant by multipath propagation. This is explained with respect to a cellular network. Cellular network means, what I mean is the mobile phone network. Okay, so this is the transmission tower, and from this transmission tower, the signal has to be given to the mobile phone, and this is called as a multipath. So just check the name. This is called as multipath propagation. What is meant by multipath? From the transmitter to the receiver, data comes through different paths. Okay, so the source and destination is same. In the previous slide, if you see, source and destination is same, and there is only one path through which the data is propagating and coming to the receiver or gateway from 1, 2, 3, 4, 5. There is only one path. In this above example also, you can check from the source to destination, it follows through these 3 nodes and it comes to the destination. But in case of this diagram, where I can see this is called as multi-path propagation, it is not only one path, but there are 4 or 5 different paths through which the data is transmitted from the source to the receiver. So what is the first signal? First is the direct signal. Direct signal is number 1. Okay, so from this tower directly the signal is coming to the receiver. This is number 1. Next is 2, ground reflected signal. So one data is coming from here, it is getting reflected to the ground, coming to the mobile phone. Third one is reflected signal by this building. So this data is coming here directly and then getting reflected here. 3. 4 is scattered signal. So it is going there, getting scattered from the lamp post, and then it is coming to the number 4. And diffracted signal. So through the corner of the building or something, diffraction occurs. So it comes here and it gets diffracted and comes to the mobile phone. So all these 5 different things, they are called multipath propagation. So between source and destination, there are many paths. If the antenna is having high directivity, what is meant by directivity? Directivity means, see that if there is a transmission antenna here, it is transmitting in very wide area. So its transmission angle is too much high. So this total is the transmission angle too much high. That means directivity of the antenna is less. Okay, so how can I reduce multipath propagation if the antenna is having high directivity? So antenna is only oriented towards this path 1 and directly to this mobile phone. Then this number 2, 3, 4, 5, all this signal transmission path does not arise. So how can we reduce this multipath propagation in this kind of scenario, cellular phone kind of scenario? If this antenna is having high directivity, then it transmits only in one direction. Okay, then the multipath propagation can be avoided. Okay, so this is called multipath propagation with respect to the cellular network. Then again I show multipath propagation with respect to the wireless sensor network. Okay, what is there? So this is the left side is the transmission antenna, right side is the reception antenna. And between the transmission antenna and reception antenna, there are many sensor nodes. You can see here there are many sensor nodes, so we can find that there are 5 sensor nodes. Okay, so data has to be transmitted from the transmission transmitter to the receptor. Then we are finding there are different 5 paths. So this is through 1, through 2, 3, 4, 5, and there can be multipath, multi-hop propagation. That this transmitter will be sending data here, this will be sending data here, this will sending data here, and this will connect to the receiver. So it can be multipath, multi-hop propagation also, which is possible within a sensor network, wireless sensor network. So these 2 are the scenarios for multipath propagation. This is the multipath propagation for cellular network. This is the multipath propagation for wireless ad hoc sensor network. Okay. So with this basic understanding, I'll go for a little bit of the syllabus material, what we are doing. So this slide is telling you about mainly 2 different kinds of communication networks. One is called as infrastructure based cellular network. In the left side you can see. Another is called as infrastructure less no base station kind of network, which is shown as the right side of the system. So in the first lecture I had explained these 2 things. What is meant by infrastructure based network? What is meant by infrastructure less network? Infrastructure based network is always having a base station. So whatever mobile phone, whatever cellular network we are having, that is actually an infrastructure based network. There is a tower and all the communication goes through here and there through the tower. Okay, so each of the mobile phones, cellular phones, they are actually talking to the tower first, and through the tower the thing is being directed to the other mobile phone. Okay, so if that is the type of communication, that is indirect type of communication, that is called as with infrastructure or base station based single hop wireless network. Whereas there is some networks where there is no infrastructure, there is no base station. What are the types of network? Wireless mesh network, WMN, wireless sensor network. So these are infrastructure less network. There is no base station. All the peer nodes, they talk to each other. All the peer nodes, they reorganize each other. So that is what is shown here, and they find out the path from the source to the destination. There is another network which is having the common property of infrastructure based as well as infrastructure less network. So this is a hybrid network which is hybrid of infrastructure based and infrastructure less network. So in this hybrid wireless network, which we'll be studying in the 5th chapter, we'll be finding the properties of both infrastructure based and infrastructure less. Both networks are present. So this diagram is very important. This is a kind of a Venn diagram. Okay, here this overlapped area, or there is a union of infrastructure less and infrastructure based thing. This will be the hybrid wireless network. Okay. Now let us find out what is a cellular network. Cellular network is shown in the left side, which is base station exists. This is the infrastructure based network. It says that presence of base stations simplify the routing and resource management in cellular network, because it is like a college with a good principal, and the principal is nothing but the base station, and he directs all the information from one place to another through itself. So the routing and resource management in cellular network or infrastructure based network is very good, and decision is made in centralized manner with more and clearer information about the destination node. So if somebody is trying to call to somebody, so that information first goes to the base station understand it is coming from person A, it has to be given to person B. So the base station knows A is where, B is where, so the base station relays the information from A to B. And whenever the base station exists, there will be a lot of power backup, there will be a generator in the base station, so there will be no loss of power, there will be no scarcity of power in the base station based infrastructure based network. So it is a very strong network with highly stable, but expenditure of this cellular network will be more, base station based network will be more. That is the downside. On the right side, on the contrary, it's a ad hoc network, and here the routing and resource management are done in a distributed manner, because there is no central base station here in the right side. Distributed manner, and all nodes or peer nodes coordinate with each other and enable communication among them. So as there is no infrastructure, there is no base station, there is no principal here, all the small nodes, they will be talking to each other, and they will be deciding how to forward the message from the source to the destination. Hence, each node is more intelligent and can function both as a network host for data transfer as well as the network router for routing packets to form or each other. So every node is a kind of a router, every node is a kind of a source, or every node can be a kind of a destination. And a very important note is given in the right side. You can see the mobile nodes in ad hoc network are more complex than nodes in cellular network. So in this case, right side, whatever sensor nodes we are having, those sensor nodes are more complex compared to the nodes of the cellular wireless network. So here are two different networks we are finding: infrastructure based, infrastructure less. Nodes in the infrastructure less networks are more complex compared to the nodes in the infrastructure based network. Here is a diagram. This diagram also you can find in the book. So here are three cells which are shown. This is a kind of a cellular phone or mobile phone network. So you can check any cell. Let us check this third cell. What we are finding is there is mobile nodes. So this can be mobile phone. Okay, so this mobile nodes or mobile sensor node or mobile phone, and they're all connected within the cell to this base station number 2. Here, all these mobile nodes are connected to base station number 3. In the first cell, all these nodes are connected to base station number 1. If the C mobile nodes wants to talk with a mobile node E, at that time C first send information to BS1, then BS1 relays the information to E. So this C cannot directly talk to E. So this is the first type, which is an infrastructure based networking. So routing and resource management are done through the base station itself, and data source and data destination points are clearly defined. So I know that the C is going to transmit data to E, and that transmission happens through base station 1. So base station 1 is like the principal. He commands, he controls the whole process. And then base station sends the data to the switching center and gateway, and from gateway the data goes to internet or cloud. So this is the example, and there is a structure and functioning of cellular network where the base station is always existing. So this is the first type. Whereas one more important, all communication takes place through base station. So these are four features of the cellular networks where base station is existing. Next, what we are going to see exactly the opposite kind of thing. This is the ad hoc wireless network where base station does not exist. You cannot check any BS here. So there is no base station here. All the sensor nodes are talking to each other. So only mobile nodes. Mobile means it does not mean mobile phone. Mobile nodes means moving nodes. So they are all moving sensor nodes. And hardware of the sensor node I had shown to you in the previous lecture. So one sensor node will be having processor, memory, sensor, ADC, DAC, and that will be having some kind of communication thing, energy thing, all those things. So there is no base station here. That is the main important thing. There is an ad hoc wireless sensor network, and this is a distributed routing happens. All are peer nodes. All nodes can communicate with each other directly. Okay, so if this C wants to talk to B, directly C can send the message to B. So each of the sensor node, each of the mobile node can talk to the nodes within its hexagon, within its cell, or it can talk directly the nodes with the other cell. So you can see here this C and B, they are from two different cells. Okay, and they can initiate talking between each other. Okay. So here I have shown in cell 3 there are 4 mobile nodes M1, M2, M3, M4. M2 can directly talk to the node with the node within the cell, or M2 can directly talk to node outer to the cell. All these things are possible. So each node acts as a host for data transfer, as well as a router for routing packets from one another. Is a very quick and economically less demanding deployment. What is meant by deployment? How you are putting the sensor within a cell. So cell means it's a hexagonal cell. Okay, so where all you are putting the or placing the sensor within a hexagonal cell, that is called deployment. So in case of ad hoc wireless sensor network, we are not worried much about deployment. Just go there and put sensor anywhere within the cell, deployment occurs. But in case of previous case, that is cellular network, the base station has to be at the center. Base station cannot be at one corner. Base station has to be there at center, because there is a principal at the center of everything. Okay, and all the other mobile nodes are placed surrounding to it. So in cellular network, the deployment is kind of a circular, kind of a centralized deployment. In case of ad hoc wireless sensor network, deployment can be anywhere. The way you want, you can deploy. So quick and economic and less demanding deployment that we find in case of ad hoc wireless network. Cellular network deployment has to be centralized. Okay. So no centralized control is found in case of ad hoc wireless network. That is main thing. Okay. These are very important differences. So two slides are there. A lot of differences uh, I have put here. But these differences you can find in book also. Some of the things I will explain, but understanding the differences are very much important. So there is a very widely asked question in the exam. What is the difference between cellular network? So cellular network is an infrastructure based network. Ad hoc wireless network is an infrastructure less network. So that is the first point. Cellular means mobile phone network, whatever we are using, Vodafone or Airtel or Jio. So that is a cellular network, infrastructure based. Ad hoc wireless network is an infrastructure less network. Cellular network, it has single hop wireless link. Why the single hop? Because from the source to base station there is one hop, and then base station to destination there is another hop. So from source to base station, that is single hop. What is meant by ad hoc network? It is multi-hop. So source and destination can be far off. Source can be in one cell, destination can be in other cell. So 3-4 more different peer nodes can be used in between to send the message from the source to the destination. So ad hoc wireless nodes are multi-hop networks. Cellular network, that is infrastructure based, guaranteed bandwidth is there. It's designed for voice traffic. So mainly initially whenever cellular network was defined, it was mainly for voice. Nowadays we are changing text, nowadays we are sending videos, audios, all those things. But initially it was only designed for voice. Okay. So guaranteed bandwidth, that means each of the central node is assigned some bandwidth. There is no interference of bandwidth in case of cellular node. Okay, but in case of ad hoc node, shared channel. So a total bandwidth is allotted to all the sensor nodes. Each of the sensor node is sharing the bandwidth. So there is a chance that data might get corrupt in case of ad hoc wireless network. So there is a best effort data traffic. So all the sensor nodes, peer nodes together, they try to send the data from transmitter to the receiver, but guarantee of the data transmission is less in case of ad hoc wireless network, because guaranteed bandwidth is not assigned in every sensor node within this ad hoc sensor network. So सब कुछ हवा में है, everything is very much dicey, everything is very much flexible. So there is no guarantee that data will be transmitted from source to the destination every time. That is ad hoc wireless network. Stability is less, guarantee is less, but yes, deployment is very easy, cost is very cheap. That is ad hoc wireless network. Cellular network, centralized routing through the base station. Ad hoc wireless network, distributed routing through all the peers. Cellular network, circuit switch network, whereas ad hoc network is packet switch network. I think you have done digital communication, you know what is meant by circuit switching and what is packet switching. Okay. Cellular network, seamless connectivity, low call drop during handoffs. So cellular network is very stable, I told you. Okay, so the amount of call drop is very less, and there is surety that yes, the call will be connected from the transmitter to the receiver. Whereas ad hoc, I told you, it's very flexible, it is very highly dynamic. There is a big chance that in between the talk, in between the call, there will be a path break, and the source to destination data transmission cannot be possible every time, or seamless transmission reception might not be possible. Yes, because there's a temporary kind of a network, ad hoc wireless network. It may be deployed for half an hour, 1 hour. It does its job in case of military application, and that's all. And after that, it dies. But cellular phone network is not like that. It is a permanent kind of a network. Whenever there is permanent kind of network, it has to offer a seamless connectivity. Cellular network or mobile phone network is high cost of deployment, because we have to erect a base station at the center. We have to ensure high energy. We have to ensure a generator based kind of a power backup in case of that base station. So high cost of deployment is there in case of cellular network. Whereas in case of ad hoc network, you just go there, you just put some sensor here and there together, and that becomes a network, and then each of the network talks to each other, they find out each other location, and yes, they start transmitting. So deployment or placing of the sensor, deployment is how well you are placing the sensors within that area. That is very easy in case of ad hoc network. Deployment takes much time in case of cellular network. Yes, because you have to erect the tower, you have to give the connectivity, you have to connect the generator, you have to put a lot of algorithm in the microcontroller of that base station, because base station has to have the whole control. So it's like a principal. It should know all the rules and regulations of communication protocol and all. That's why deployment is it takes much time in case of cellular network. Whereas ad hoc network deployment is easy, because there is no base station. Just go anywhere, just place some sensors, just throw some sensor nodes and come back. That's all. Okay, so it is deployment is easy, deployment is cheap, deployment takes less time, quick. It is like that. Synchronization is easier in case of cellular network, because it's following a certain rule. It is controlled by principal base station. But time synchronization is very difficult in case of ad hoc wireless network, because some node may be on, some node may be off, some node may be at sleeping kind of thing, some node may be active. So not all the nodes are active at the same time in case of ad hoc wireless network. Hence, time synchronization and all this process becomes a difficult task in case of ad hoc wireless network. The reuse of frequency spectrum happens for geographical channel reuse, and reuse of frequency spectrum happens through dynamic frequency reuse in case of ad hoc wireless network. So these are main differences as far as its infrastructure, as far as its connectivity and deployment kind of things are concerned. Now let us see the application part of it and bandwidth part of it. From there, how the cellular network and how the ad hoc network, they are different. So cellular network, we can find out it's easier to employ bandwidth reservation, because every cell phone is given some kind of bandwidth. So that's why transmission reception of data is ensured in case of cellular network. Whereas bandwidth requires complex MAC protocol. So a lot of sensors are deployed together in one place, and they all are asking for the same bandwidth. So they get, if more number of sensors are deployed, bandwidth assigned to each sensor node will become very less, will become very narrow. Okay. So in case of ad hoc sensor network, what we are finding is bandwidth requires complex MAC protocol. So MAC protocol we are going to see in the next lecture. What is MAC protocol? Medium access control protocol. Okay. So how the data is extracted by ad hoc network from the same bandwidth. Okay, so that actually is MAC protocol. We'll see that. Okay, application domain for cellular phone, obviously civilian and commercial sector, but application domain for ad hoc network is disaster management, battlefield, rescue operation, collaborative computing, and military application. For this, ad hoc wireless networks are applied. So this thing you understand very clearly. Cellular network is applied only for civilian and commercial, whereas ad hoc network is having rescue, a very kind of flexible kind of operation. So any kind of operation you can use it: military, rescue, disaster management. So wireless sensor network, IoT, cloud computing, all these things come in case of ad hoc wireless sensor network. And very good projects can be defined in the domain of ad hoc wireless sensor network. And this is having cheaper cost, this is having quicker deployment. But yes, you have to define, you have to design your own sensor nodes to create a ad hoc wireless sensor network. It can be Zigbee based, it can be IR based, it can be having some other communication protocol and all. But yes, designing this kind of thing is much easy. Network maintenance cost is higher in case of cellular network, and self-organization, and it is kind of a maintenance free. Ad hoc wireless sensor network are maintenance free, but yes, node dies and they go out of the whole network. That is also possible. Mobile hosts are relatively low complexity. So whatever mobile phones are there in case of cellular network, they are comparatively complex. Their hardware is, sorry, comparatively less complex. So the hardware of mobile are comparatively less complex because they are not the decision makers. They are just sense the data and transmit. That's all. The main communication decisions are taken by the base station. Whereas sensor nodes in case of ad hoc wireless sensor network, they are very complex. They should be having sensing, they should be having processing, they should be having communication, energy, all these things, routing, switching capability, all these things should be there in the sensor nodes of ad hoc wireless network. So this is a very important point, that whatever nodes are there in cellular thing that are less complex, and whatever circuit nodes are there, mobile nodes are there in case of ad hoc wireless network, they are very complex because they have to do a lot of things. They have to do a decision making, routing, switching, all those things have to be done. What is the major goal of the sensor nodes which are placed in cellular network? So major goal is just to transmit the call, accept the call, and just for voice transmission. That's all. Okay. So major goal in routing and call admission are to maximize the call acceptance ratio and minimize the call drop ratio. What is meant by call drop ratio? How many calls are made and how many calls are dropped? How many calls could not be completed? So call drop ratio is call dropped divided by how many calls are made. Okay, and the call drop ratio should be as less as possible. If not a single call is dropped, then call drop ratio is 0. In that case, the call acceptance ratio is 100%. So that is a major goal of the cellular network, that no call should be dropped. Anytime, anywhere is calling somebody within the cell or outside the cell, the call should get completed, data should be transmitted from one place to another without any kind of hassle. That is cellular network. Whereas ad hoc network, what is the main aim? Main aim is to routing the data from one place to another. So finding the path from the sensor sensing node to the destination node without overloading the other peer nodes. Not necessary that you have to follow one path. Sometimes you have to reroute, and so that one path should not get jammed. It is like going from one place to another by means of a road. So if all the traffics are passing through one road, the road gets jammed. Okay, that should not happen. So you have to see that all nodes are having same traffic density, and data is transmitted from the transmitter to the receiver without much hassle. It reaches the receiver in due time. So routing is the main issue in case of ad hoc wireless sensor network. So left side cellular network, main issue is maximize the call acceptance ratio to 100%. For ad hoc wireless network, the main issue is how to find the path from the source to destination. If one path is broken, then reroute it. So one road has become blocked, suddenly reroute it so that the traffic is not getting congested. The traffic should be free flowing, it should be easy flowing. Data should reach from source to destination without any kind of breaking. Okay, so that is the main aim of ad hoc wireless network. Last thing, widely deployed and currently in book it is written 3G third generation, but actually the book was written long back, so I have made it 5G. So the cellular network is widely deployed because everybody is now having a smartphone and now we are using 5G. But ad hoc wireless network is still having a lot of issues to be resolved. Okay, so this has been this wireless sensor network is used for ad hoc network is in use for last 20-30 years, but there is no very specific kind of protocol and algorithm and basis for this developed so far. So even though while military applications exist, but there is no very successful commercial deployment and successful commercial protocols which are available for ad hoc wireless network. So why you have taken this subject is because you want to give some new kind of protocol, you want to define some new kind of hardware so that this ad hoc networks also can be standardized, their performance can be standardized, their protocols can be standardized, and all those things. So these two slides are very important to understand the very basic conventional cellular network, its performance, and ad hoc wireless network and its performance. Let us go through the applications of ad hoc wireless network very fast. So I told you that it is military applications, and mainly military application is just you have to throw the sensor nodes into the area that you want to track, and maybe very fast the networks will act and then they will die. Communication among group of soldiers, coordination of fast moving military fleet, okay, secure multimedia, multicasting possible, secure communication, quick, secure, reliable multicasting. So multicast is another thing. So we have seen multi-hop, multipath, multicast and multipath. I think they are same. Okay. So like that. So and what it actually uses is collaborative and distributed computing. Okay, collaborative means all the sensor networks are like the router, they are peer nodes. Okay, so all together they send information from one place to another. So there is no base station, there is no fixed infrastructure. Okay, heterogeneity is very high, security is low, because any sensor node can be tampered. Any sensor node, if tampered in ad hoc network, your security is breached. So that is one thing very important. Okay, for group of people in conference or gathering, we can deploy a collaborative or distributed computing kind of a sensor network. Emergency operation, rescue operation, quick search, quick control, self configuration network, we can deploy ad hoc sensor nodes. Last thing before we end today, so this is another application of ad hoc wireless network, which is called as wireless mesh network. This can be asked in the exam. So there are two networks explained in the left side. You can say residential application. So there are a lot of houses, and each house can be is depicted like one sensor node. So each house is having one transmission antenna, and they are having a transmission range, and all these six houses they actually can talk to each other by using the ad hoc wireless network, and together as all this their sensing ranges are overlapping, they are actually creating a mesh kind of a network. So all these things together, they are producing a lot of data, and through one communication channel, so which is shown by this dashed line. So this you can find, this diagram you can find in the book of whatever book I forwarded, page number is given. So all the sensor nodes together, they are again generating a huge amount of data, and through the wired link they are sending the data to the next gateway. Okay, so this is the gateway, and from this gateway thing is going to the internet. So this is one application, that residential internal ad hoc network, and they are connected to the through the gateway, they are connected to the cloud. Same thing happens in case of highway application. So in highway, beside there are a lot of roads. In highway there are lamps that can be connected to the internet. So this lamps, this highway control tracking, all this can be tracked by internet from a far place. Okay, so this is multi-hop radio link, and this is wired link, and all these things. So all these things together can put region wise within a ad hoc network, and they can be connected from this gateway to the internet by means of a wired link. So these two are small applications. A little bit explanation is given in the book, and this is actually the same thing what we have seen. Left side there is a wireless sensor network properties. So these are properties we have already seen, that wireless sensor network is having a lot of mobility. Size of the network is big, density of deployment, highly dense nodes we are deploying. Power constant is there because every node is having battery, and within that battery it has to run itself. So replenishable power sources. So whenever the battery gets exhausted, we have to go and replenish the battery there. We have to change the battery. Data information fusion. So a lot of sensors are producing a lot of data. All the data has to be put in the base station, and at the base station there happens data fusion, and one inference is drawn. And last thing is traffic distribution. So we are supposed to find out what is the path from the source to destination in case of wireless sensor network. There is one thing called as hybrid wireless network. This hybrid wireless network is actually a mixture of, this is actually MSMCN, multi-hop cellular network. Okay, this is an application of ad hoc wireless sensor network. This hybrid wireless network is actually putting cellular network and ad hoc network together. So here you can find there is base station based communication, which is called indirect communication, and there can be direct communication as well between two mobile nodes. Okay, so this thing, short note is asked, what is meant by hybrid wireless network? You have to say hybrid wireless network is actually a combination. So this is latest kind of a network, which is called HCN. Application is called as MCN, multi-hop cellular network. This is actually combining both the features of cellular infrastructure based network and ad hoc infrastructure less network. And how do you know this is adding the feature? Because in this case, the communication between two mobile nodes can happen through the base station indirect, as well as they can happen directly. Okay, so this is hybrid wireless network, which is a combination of cellular and ad hoc. So this slide I'm not going to explain. This is the last slide, which are issues in ad hoc wireless network. So when we are starting the next session in another 11-12 minutes time, we are going to start with these issues, which are the issues of MAC protocol. Okay, so this is the issues in ad hoc wireless network, and I'm leaving this session with this slide in front of you. So that's all from me from this lecture. So see you here exactly at 12 o'clock. So there is only 10 minutes time there. So please join at 12 o'clock. The link will be the same. We are not going to use different link. Link will be the same. Thank you.